Take it away, guys.
Thank you, and thanks Digital Asset for hosting this, and New York Haskell User Group for inviting us to present tonight. My name is Todd Sundsted. I'm the CTO at SumAll, and with me is
Michael Ho, Senior Engineer at SumAll.
And we're going to talk a little bit about the transition that we made starting as a Java shop and going to a Haskell shop, or becoming a Haskell shop. Just a couple words of warning. This is like the least technical talk you're probably ever going to hear here. So we're not going to dive into tremendous technical detail, although we do talk a little bit about the technology. That's the main thing. I guess the other thing is we don't have slides. So it's just like us talking. So I don't know what you look at if you get tired of looking at us. So I guess the topic, like I said, is SumAll starting as a Java company and becoming a Haskell company. And I think for most of the folks here, that's probably kind of obvious at one level and maybe a little mysterious at another level. It's obvious because, you know, I suspect most people would probably prefer to program in Haskell, I'm guessing, over Java. I see a few nods. So I'm guessing, I'm taking that as a given. But maybe a little mysterious too in terms of the why and the how that we went through to do that. So when I talk about starting at as 100% Haskell, when Michael and I joined SumAll, all back-end development was in Haskell, or Java. Geez, I can't even remember what I'm doing. Yeah, so all back-end development was in Java. And what that meant in practice was that we had two large monolithic servers, one handling the front end, one handling the back end, and one giant common library of code. We were running on top of in a clustered configuration on top of a technology called Hazelcast, which provided distributed data structures like queues and lists. And we had 8 back-end developers basically doing Java full-time and building on that. When I say that we went to 100% Haskell, you're getting it right this time. So today, basically, we're at nearly 100% Haskell. And in particular, we have maybe 2 exceptions to that. We have one legacy Java service that's still in production, and we have one legacy Python service. And we'll talk about the overall metrics and scale of the operation a little bit later, but we have quite a few microservices in production use right now. The timeline for this, just to give everyone a sense of things, we actually took our first steps down this path in June of 2014. So leading up to that time, and both Michael and I were on board at that point, we were doing Java development. About a year and 8 months later, so just double check, February of 2016, we were about 50-50. So a year and a half later, we were actually doing 50% development in Java, 50% development in Haskell. About a year after that, February 2017, at that point, 100% of all new development was actually happening in Haskell. We had some historical systems that were primarily in maintenance mode. At that point, providing service for a paid product that we offered. As of basically this month, we're in the process of shutting those down and moving that remaining functionality to our Haskell environment. So a year ago, all new development was in Haskell, and then within the next short little bit here, really most of our system, except for like 2 legacy services on the back end, will be in Haskell. So, like I said, probably for most of the folks here, the decision of why is obvious, right? But what I found fairly quickly is once you go outside of this room and kind of mention that, hey, we were doing Java, now we're doing Haskell, the first reaction is usually like, why would you do that? And the question is kind of obvious, right? Java is an immensely popular language. There are boatloads of successful companies that have built their applications on top of Java. And I mean, I underscore successful, right? They're making money, they're doing useful things. And of course, there are boatloads of happy Java developers as well. In our particular case, I think if you want to understand the motivation a little bit, it makes sense to actually look back at Java itself kind of in the time frame of 1996 to about 2000. So I had been involved with Java in that time frame. And what I learned at that point was that technology changes can have a huge impact on industry. So something as simple as the development of Java and the adoption of Java literally created new industries. It had a huge, tremendous impact, a tremendous economic impact. And it was simple things about the language and the platform, right? Sun's marketing hype aside, it provided a very simple object model in comparison with, with C++, for instance. It provided managed memory, which was actually very convenient. It came with a kind of a web-ready library of utility code. It provided static typing, which was useful if you'd been doing, say, Perl at that time. And it came with a very familiar syntax. So, that package together was very potent, and of course Java did very well. So the thing that I was interested in understanding was, could functional programming do the same thing, right? So could the adoption of functional programming, and forget about Haskell for a moment, could functional programming as a paradigm bring about that much benefit? And I was super interested in exploring this. It was, questions about, does a functional programming language help you build more correct code? Does it reduce the maintenance burden? Does it reduce the number of bugs? Does it result in a more robust service? Or does it do some things that I'm not even thinking about when I say these things? And of course, I wasn't like alone in thinking this, right? You look outside and you can find examples of luminaries saying almost these exact things, right? You can think about Ordersky talking about Scala, for instance, or Rich Hickey talking about closure, right? They were making very solid claims about what you could accomplish there. And I wanted to see if we could get some of that. So in addition to those kind of very ambitious goals, we had some more modest goals around recruiting, for instance. So as a Java shop, and really pick your technology, Go, Ruby on Rails, whatever, but certainly as a Java shop, if you recruit, the recruiting dynamic consists of you sitting with a candidate and going, hey, you should consider my Java shop over the 3,000 other Java shops in New York City. Let me tell you why. Whatever, unlimited vacation, we got a kegerator. You're trying to pitch them literally on, why you're different and better. What I wanted to do was take a page out of Google's playbook. So Google had jumped on the Python bandwagon early on. They had identified a group of kind of passionate developers with solid technical skills and had started recruiting Python developers. And they picked up a lot of very good talent by going down that route. And so I wanted to see if by picking something like a functional programming language and picking something like Haskell, if we could change the dynamic from, hey, here's how we're different from 3,000 other companies, to, hey, if you want to come and do large-scale production Haskell development, come and talk to us, right? We're doing it in production. We're doing it at a large scale. You should come and talk. So the recruiting angle was important as well. So the other question I just want to touch on really quickly is, why Haskell? If we were a Java company, obviously there were functional languages on top of the JVM, Scala and Clojure, for instance. So there were other constraints in play at the time. Before we'd even considered looking at Haskell, we'd already made a decision to head down the road of microservices. So we'd taken this big monolithic application and we'd started to look at ways to break it up and build a set of microservices. And furthermore, we'd made a decision to build on top of Docker. And what we were learning was that Java microservices, the JVM on top of Docker is a tricky configuration to get right. Your images are large. I was talking to other companies that were doing Docker, and by building things that compile down to native executables, they were able to get very small 1 gigabyte or 1 megabyte, 20 megabyte, 10 megabyte, whatever, Docker images And I wanted that, right? So that kind of ruled out picking the JVM and pushed us towards the direction of something that we could get a native executable on. So at that point, maybe we had Haskell and OCaml to look at. If I'd made this decision maybe 3 years before, I probably would have went down the route of OCaml. It's a language that I had spent a little time with, and in town, Jane Street had already started making a tremendous investment in it. So it would have made a lot of sense. The deciding factor for us at the point, or one of the deciding factors on the Haskell side, was multi-core support, which OCaml still is struggling to get in, and we really kind of wanted. And I think the other factor too that played in when we started talking about this as a team was this desire to kind of go all in. If we were going to do functional programming, why pick a language? And I had done some Scala, and when I did Scala, I was really doing it as an enhanced Java, right? So I was skirting a lot of the challenge and a lot of the opportunity by picking the easy parts. So, to some degree, we wanted to go all in, right? Let's pick a language that forces us to really learn to deal with functional programming and all the other bits and pieces. So that's kind of the why. And there were a couple of extras as well. I'd hired a really good distributed systems engineer who'd done some prior work in Haskell in production. So we had a ringer. We had someone on the team who we could count on to help bail us out if we got into trouble. And I had worked with a guy at Bloomberg who had left to start his own consultancy, and he was building that around Haskell as well. So I knew that if I once again got into trouble, I had a few places I could reach out to that would give me a little respite. So the reason that I jumped into the why, in addition to giving you a little insight into my thinking, was if you're in an environment where you're trying to make this pitch, right? You're doing Java or you're doing, whatever, pick your language, and you'd like to introduce functional programming or go all the way to Haskell, you have to think through the pitch you're making. And so these arguments were kind of the things that I was putting together so that I could persuade the team as a whole that this was a direction that was worth going down. So once again, the things that I think that I would tie into this, we were doing Docker, doing microservices. We wanted something that ran well in Docker. We wanted to explore functional programming to see what gains we could get. And we were really hoping to see if there was a return on the recruiting side. So I want to talk a little bit about the how, but I just want to make one more point too, the how of how we made this pitch. At this point in time, when this happened, I wasn't actually the CTO of the company. Presumably, if I'd have been the CTO, I could have waved a magic wand, and maybe we would have all just started doing Haskell. But at this point in time, I was literally just a senior engineer on the team, and I had to actually convince people that this was a direction that we wanted to go. So let's talk a little bit about that. To pull that off, I had to do three things. I had to convince leadership, obviously, that this was a direction that was worth putting an investment into. We had to swing the team around, and then we ultimately had to find a way to achieve success with all of this. It turns out that pitching the manager, the senior leadership, was actually the easy part. SumAll's culture was always focused quite heavily on innovation and experimentation. So there was already kind of a preset assumption that if you're doing a startup, and this is not universally held for sure, but in the case of SumAll, if you're doing a startup, part of what you're trying to do is experiment with something, right? That's why you're doing a startup. So you want to take some risks, take some chances. So really what Dane, who was the CEO or is the CEO, and David, who was the CTO at the time, wanted to see was what was our plan, right? The notion of trying this experiment, not crazy, but ultimately we want to see a plan there. And so we'll talk a little bit about that. Swinging the team around, as you can imagine, was a lot trickier. We had 8 developers with a group that size. You're guaranteed to have a few people at least who are not going to be excited about the change or about any change. And so we had to find a way to kind of bring them on board. So in doing that, I kind of fell back on what's really kind of change management 101. So if you read up on how to affect change in an organization, there's like 3 points that they always talk about, and really this is the core of the talk from my perspective tonight. if you have to ever do anything like this, right? It's like step number one, gather together the champions, find the people that are interested and get them on board. Then grab all you and the champions together, go for all the people that are undecided, right? Go after them, and the people that can be persuaded by an argument, grab them, help them understand, get up to speed, and go. And then basically step number three, the only thing you can do with the rest is outrun them, right? Outrun the detractors. You have to be productive with what you're doing so that anybody who's just naysaying without a solid reason for naysaying is going to just have a hard time keeping up. And really, like I said, that's the core. That was literally the strategy. So I grabbed two engineers, the one guy who had already done production Haskell work, who I thought I could count on, and then another engineer who had expressed interest in doing Haskell. That was the champions. We recruited one of the undecideds. That was Michael, who's going to talk about that side of it. He's very much decided now. I hope I didn't paint that in the wrong picture. He's been a frickin' champion too. And then literally we ran like hell, right? I mean, we really went for it to make this thing work. And so that's kind of the second part of this is the running.
So at this point, we had, as Todd mentioned, we had buy-in from our upper management to start doing this. So we were ready to tackle the next big barrier to entry, which was just learning the damn thing, learning Haskell. As people in this room might know, or might be familiar with, Haskell is a difficult language. It's notoriously intimidating and difficult to break into, right? So we wanted to make sure that we could, in fact, have people learn Haskell in a reasonable amount of time and become productive in it. So we decided to run an experiment. So we took one of our engineers who hadn't done functional programming before, and we had him go and learn Haskell, and we wanted to see, could he be successful and become productive. This engineer had only done Java his entire professional career, had no functional programming experience. He was also a very good-looking man. It was me. So at this point, this was like August of 2014, and Java 8, which introduced lambdas to Java, had just come out that March, right? So this was a very recent thing, and I had not done any Java 8 at that point, so I really had zero functional programming experience. And also at this point, the Haskell from First Principles book was not out yet. I mean, that only came out like a year ago or so. So there really was a bit of a lack of good learning materials. So how did I do this? So there actually is a great course, online, well, not online course, a great course from the University of Pennsylvania. Some people might know of it. It's called CIS 194. And they make all of their teaching materials online, their lectures and their homeworks, free publicly. And that was the main resource I used to learn the language, and it was a really great resource. I used the spring 2013 version of it. I also supplemented that with some reading from Learn You Haskell, and also with a lot of support from my two colleagues who were already familiar with Haskell. So I did it, I learned it. Took me a long time. I'd say it took me about 2 months doing it almost full time, like 80% time, before I really felt comfortable enough to be productive and writing code myself independently. All right. So at this point, okay, we proved that we could learn Haskell. We then had another one of our engineers also take the plunge and learn Haskell. So at this point, our fledgling Haskell team was comprised of one expert level Haskell user, one intermediate level, and two newbies, one of which being myself. So now we were ready to actually start doing some stuff. But of course, moving to any kind of new language, there are a lot of infrastructural things you have to take care of first. For one thing, we had to add support for building Haskell artifacts to our build pipeline, which previously was only building Java stuff, was using Maven and Nexus. Now we have to add Cabal support to it. And by the way, at this point, Stack did not exist. This was like early 2015. Stack's beta, I just looked up the other night, came out in 2016, and I cannot believe it's only been like 2 years since Stack exists. I cannot imagine a time without Stack. Thank you to FP Complete. And of course, there were other things we had to take care of too. Our deployment infrastructure, we have to support Haskell there. And we had to write pretty much from scratch a whole bunch of just internal business libraries and frameworks because we were moving to a brand new clean sheet language. Haskell being a not as popular language, to put it mildly, you're not going to find a lot of official support for like client support for systems. So one big example of this was at the time we were using Netflix's Eureka system for service discovery for our microservices. Netflix being a big Java and Scala shop, they had great support and official clients, Java and Scala clients for Eureka, but they didn't have one for Haskell, so we actually had to write our own client for Eureka. We also had to learn how to properly version our applications because in Maven, it would just automatically increment the versions and ad hominem or just forever, and you would get versions like 4.1.2 a million or something, right? You never have to think about versioning your system. Well, in Haskell, of course, Haskell has its own PvP versioning system, which I've grown to really love. So we had to learn to do that for ourselves. So another big challenge to Haskell, besides learning the thing, is that Haskell has a very high skill ceiling. Right? It's a little bit, it's difficult to get into, and once you get into it, the sky's the limit, right? You can really go nuts with language extensions and features and crazy stuff, and make your code, really cool and really powerful, but completely inscrutable to anybody who's not familiar with those features, right? So one really great thing that we did, and our ringer, his name is Rick, that Todd mentioned, and then he really made it a point to keep us reined in, right? We had established generally a very conservative style of using Haskell. There were a lot of things that we shied away from because, frankly, while those things are cool, we don't need it to be productive. Right, and we're optimizing for accessibility because we had a bunch of people who were brand new to Haskell, and we want to bring on board more people, and we want our code base to be accessible and understandable. So, so as far as language extensions go, like type families and JDTs, that level is about as far as we go. I might get flamed for this, but we also stay away from lenses. We feel that we feel that lens. It's cool. You can make your code very terse with it, but it's like adding a whole new language. And there's all these operators and the squigglies, and you have to learn the prisms, and all the things you do with lens. You could do with more basic mechanisms, right? With just pattern matching. Yes, it'll be wordier, but you can accomplish the same thing, and it's a lot more understandable, right? It did take us a while to settle in on a single web framework. For a while, we were using Snap, and then for a while, and then we moved to Scotty for a while, and just more recently, maybe in the last year or so, we settled on Servant, which is a really cool framework. We also did a little bit of work with the operational monad, which didn't turn out very well. It made that bit of code that we used it on very complicated. It's possible that we were just using it wrong, but we haven't gone back to try it again since. I don't know. And as far as style goes, specific style points, we made it a point to always use explicit exports and explicit imports or qualified imports. Because there's nothing more frustrating than reading Haskell code, especially for a newbie, to come across a function that you've never seen before and have no idea where it came from or what it does, because you can't, it's not mentioned in the imports anywhere, and you're going to have a hell of a time figuring out where to look for this implementation.
Cool. Thanks, Michael. So I want to zoom forward, or maybe zoom backward actually really quick again, and talk about kind of what it means to be doing 100% Haskell. I'd mentioned that I was going to talk a little bit about the scale that we're operating at, just to give you a sense of things. So at this point in time, we have about 100 Kubernetes pods, which would be like a Docker instance running in production. and about 23 different microservices. So we're not massively huge scale, but it's not a toy application as well. We process data for about 300,000 active users. We pull their data in about every 2 hours. We generate reports. So we send probably 300,000 plus emails a day. And these aren't just marketing emails. I mean, these are reports based on their data. And we run probably 200,000 automations on behalf of those users every day. So it's a decent scale operation, not massively huge, but once again, not a toy. And we have 5 full-time Haskell engineers right now, so a slightly smaller team. And they're doing essentially 100% Haskell development. Some of them do a little work on the front end as well. We tend to build our teams kind of feature focused. So some folks, in building that feature will make the front end changes as well as work on the services on the back end. And we got there along the path that you'd probably kind of expect, with maybe one twist and turn in the past. So we hired some folks. We actually hired 5 people. We found 2 people with existing Haskell background, and then 3 people with general functional programming background. We converted, 2 to 3 members of our team, 3 if you include myself. And then ultimately we shrunk a bit by losing some folks. So in 2016, right at the beginning, we made a fairly large pivot in our product line. And since we were changing our product line up and investing really in a new set of features, in addition to reducing the size of the company somewhat, we also were in a position to kind of move away from supporting some of the technology and some of the services that we didn't so much want to support. And what I'm saying in a roundabout way is we moved away from Java fully at that point. The last 2 kind of full-time Java developers left, and we put all the rest of the Java services kind of in maintenance mode and really went full on 100% on the Haskell side. And at this point, like I said, we're really doing full Haskell development with a couple small exceptions. So the one thing I want to touch on before turning it back over to Michael is how do we do? So I outlined some maybe ridiculously ambitious hopes and dreams for this project, right? In terms of what we could accomplish, and then maybe a few more modest ones. So on the hiring front, which is one of the more modest ones, there's no doubt in my mind that we were able to attract, retain great developers, and I'm emphasizing great. The quality of people that we found really surpassed what I've encountered in a lot of different areas, right? And it kind of makes sense. If you're doing Haskell development, you're not doing Haskell development because someone hired you, trained you, or you took classes in school to learn it and became a Haskell developer. Maybe it's more common now, but generally speaking, you probably got there because you damn well wanted to learn how to do functional programming and you wanted to learn Haskell. So, you're just going to be oriented, I think, a little bit tighter in that regard. And there's also no doubt that we actually changed the recruiting equation. We had people contact us who'd found out we were doing Haskell development and say, hey, I really want to do this in production. Can I talk to you about working there? Which is tremendous. If you're trying to build an engineering team, you know exactly what I mean. Having people actually approach you to do something is like 2 orders of magnitude easier than going out there and trying to do the other side of it. The other thing I want to say is we have a remarkably stable system. Certainly in comparison to any other system I've worked for, definitely in comparison to the previous Java system. Previously in the logs, you would find, pages and pages of null pointer exceptions with stack traces, clearly indicating something had gone wrong. But what? The Java system or the Haskell system, much more stable. We really don't have problems. Once we have everything tuned, we really don't have problems other than maintenance issues because a partner's API has changed. That's typically the thing. Things run very stably and very predictably and consistently over time. And once again, maybe these are not surprises to anyone here, but if you're not doing large-scale production, Haskell, you can absolutely get a super stable system. I would say that productivity is no worse than it was when we were doing Java, but I can't say it's actually better. Either. So from, kind of the, is functional programming going to just absolutely change the world? I don't think so from like a productivity perspective. Maybe it's a little more productive, but maybe that's offset by some of the, parsing the other person's code. But I'm optimistic too. I mean, I still have kind of this solid dream that we're going to build much better systems when we kind of get everybody on this page. So yeah, so from that perspective, I think better system, but not a clear win in terms of kind of some of the earlier goals that I set. But the game is still afoot, and there's definitely a lot more interest. Haskell itself has made a lot of progress, even in the time that we've been using it, in terms of kind of overall features and stability.
So I'm going to continue that thread and talk about some of maybe the drawbacks of using Haskell, because there are some. So like Todd mentioned, the system is overall very stable. There are very few mysterious errors happening in our logs. But when errors do happen, they are extremely mysterious because, of course, you have no stack trace to tell you when and how and where errors happened, right? One very specific and war story I'd like to share with you is this is not a mysterious Haskell language problem we ran into. It was more of like a GHC environment problem. So like Todd mentioned, we're nowadays using Kubernetes. If you're not familiar with Kubernetes, it is a system. It's like a deployment. It's an infrastructure management system where you have, instead of one server per application, you have one large server, and you dump a whole bunch of different applications on it, and you carve out resources from the big server and allocate them to the applications. So we had just moved over. We were using Haskell, and we had just moved over to using Kubernetes, and we found that our performance was dropping rapidly over our services. More like something's wrong, and this was happening over months, and our operating costs were through the roof. So we had two of our engineers, Rolando and Giovanni. They're not here tonight, but they did a lot of tremendous work, experimenting and profiling, and they finally figured out what the problem was. And the problem was that we were not setting the -n flag on the RTS settings at the parameters, okay, for the Java runtime. So if you don't set that flag, and by the way, this -n flag, what it does is you explicitly tell the runtime, hey, application, you have this many CPU cores and capabilities available for you to use for concurrency, okay? If you leave that flag off, GHC will go ahead and try to detect the number of cores itself. Well, when GHC does this, it detects the number of actual physical cores on the giant server that this application is on. So it thinks, oh, I have like 32 cores to use, when really you only have 4 allocated to you. So it was allocating a number, so the runtime was allocating a number of OS threads that was appropriate for 32 cores, but it really only had some number much lower than that. So we were experiencing thrashing all over the place. And so we finally found a fix to the problem, which was set the flag explicitly and tell GHC what number to use, right? So anyway, some other drawbacks of Haskell. As a lazily evaluated language, that opens an entire world and class of memory problems that we never had to think about before in other kinds of languages, right? And that certainly adds another bit of cognitive load to our plate. And as I mentioned before, Haskell is a more difficult language to learn, so there is a longer ramp-up time for onboarding people. So as Todd also mentioned, productivity and maybe even system performance, it wasn't like an order of magnitude big win, at least for us as we've experienced it. It's possible that it's because of just the domain that SumAll is in. We're doing a lot of web services. We're just waiting on I/O all the time. We're making a lot of web calls. It's possible that our application is just not as suited for Haskell's strengths as perhaps maybe a more computationally intensive application. You might experience more gains there, maybe. So what advice would we have for other organizations who want to take this journey and take this plunge, right? So as Todd mentioned, this kind of big organizational change, it's really not that unique. Moving to Haskell is not that unique in terms of making a big organizational change. You need to find your champions. You need to recruit the undecided and convert them, and then you need to just outrun the naysayers. And this whole process was definitely made a lot easier by the fact that we had just moved on to a microservices architecture, right? Which would allow us to introduce new components, new Haskell components to the ecosystem that coexisted with the existing components, without having to make a big change all at once. So the systems, the new systems, could coexist with the old systems, and the new guard, the new engineers, the champions, could coexist with the existing engineers, right? Until we can convert them. And our original goal wasn't to go to 100% Haskell. I mean, all we really wanted to do was introduce Haskell to our ecosystem, maybe go for 50-50. And we did, in fact, get there. We got to a point where we were like, 50% Java, 50% Haskell. But then we laid off a whole bunch of people, and we happened to lay off all the Java people. So, hey, there we go. That pushed us over the edge to 100%, right? So, I mean, this experience, and on top of it, we had a product relaunch and a big rewrite, which, again, gave us a unique opportunity to shed a lot of our old code and write exclusively in Haskell. So those things are maybe unique, right, to what happened to us in our history. So if you want to bring this change to your organization, maybe you're going to have to temper your expectations. You can't expect to go to 100% unless you're going to lay off like a whole bunch of the company, right? So, and a kind of change like this is probably, in our experience, more likely to happen in a smaller startup company, which you may describe as nimble, or more cynically, you might describe as more unstable, right? The big product rewrites, the layoffs, those definitely contributed to our ability to go to Haskell. As Todd mentioned, that there was it did make recruiting easier and better for us because people were now approaching us, to come work at the company. But what we found is that still the volume of people who would be coming through our doors is not great enough to support an engineering team of, let's say, in the hundreds. Of course, we're a small company. Right now we have like 10 engineers. So maybe for a team of 10 to 40 engineers, moving to FP with the goal of recruiting more people could be okay, but you might be hard pressed to fill a team with like hundreds of functional programmers. It's also important to have a critical mass of people who are willing and able to maintain these new systems. Because one of the toughest parts about introducing a new technology is the bus factor. If somebody writes a thing that nobody understands and then they leave for whatever reason, well, the company is now screwed, right? You need to, in order to get management buy-in, you need to establish that critical mass first of people who would be able to maintain these new systems. And unique to Haskell, because Haskell is a more difficult language to learn, you really want to make sure that you have a good plan for bringing people on board, a good learning plan and good learning path. Prepare those materials beforehand and have those ready, and have mentors at the ready to help people come on board. And again, it really helps to have a sort of a more conservative stance on using Haskell's features. It keeps your code a lot more accessible, a lot more readable, and it really aids in onboarding people. So that is the story of how we moved to Haskell. And we are hiring again, even though we laid off a bunch of people before. We are hiring back-end engineers. So check out SumAll.com. Todd has business cards. And thank you very much.
I think we've got a couple of minutes for questions. A question if people have them. So, of course, you can grab any of us if you want. Go ahead.
When you're sort of measuring productivity, what factors are you using to say you were more productive or less productive? And was that sort of felt by the rest of the business?
Yeah. So the question was what metrics we were using to determine productivity, and honestly, nothing particularly scientific at all. Just looking overall at the kind of overall speed with which we were getting features out. Once again, with a something as unspecific as that. There could be a lot of factors, that contribute to that. I'm not good at measuring anything that's like less than an order of magnitude, literally. So I'm pretty sure it wasn't 10 times more or less productive. It actually might be more productive. The team actually really prefers it, and that to me matters probably even more so than raw productivity. So yeah, not super scientific. Go ahead.
Actually, to follow up on his point, you said that you were getting a lot less, you were getting a way more stable system. So that would be part of the productivity metric. So I would think that even though sure the figure is coming out at the same time, the fact that you didn't have to fix bugs later, wouldn't that be an increase?
Yeah, so was pointing out that just having a more stable system is likely to improve productivity overall. And that's a legitimate point as well too. Take my comment about order of magnitude pretty accurate. I just, it's hard to get a good gauge at less than that. I think the stability, the fact that you're not dealing with the same irritating problem over and over again, you just have some confidence in what you're doing is important. In the back.
About security. So how does that affect your security stories?
The question was, how did Haskell affect our security story? I mean, Haskell itself, I guess I wouldn't say changed the security side of it. I'm not, we're not moving anything. I guess most of the concerns I would have on the security side are probably more around the overall system and access security. Haskell itself, I don't know that I'd attribute anything to, but we can talk about that. Maybe I'm misunderstanding your question too. Go ahead over here and then I'll go over that way.
You said that when you were a Java shop, you had to compete with all the other Java shops for people. And now you do Haskell shops and you only one of few. So does this mean you have to get the developers cheaper?
No, that's, so yeah, so the question, if everyone didn't hear it, was,
How much do I lose by going in the market as a Haskell developer versus a Java developer?
yeah, so it's an interesting question. Let me think if I can. I don't know that we bias that. So the question was, is there any maybe kind of premium, maybe, or I guess kind of negative you take on by pitching yourself as a Haskell developer on the market? I mean, I certainly wouldn't say that's the case right now. The concerning thing for me is there are actually quite a few places in New York now that are doing Haskell development. So I don't feel nearly so like there's so much advantage there. I mean, the other thing I would say too is the people that we talked to certainly understood their value, and they certainly weren't afraid of trying to find, trying to bring that to bear in a negotiation. I certainly don't think we were getting them like half price or an order of magnitude less. That would have been really awesome. Go ahead.
So you both alluded to this a little bit in the talk, but one of the things you get with Java and the JVM is this huge ecosystem, a lot of open source, a lot of outside systems that plug into Java and monitoring and maintenance and things like that. What kinds of things do you miss working in Haskell for not having that ecosystem?
Yeah, I'll let Michael say that one.
The question was, do we miss anything about the big JVM ecosystem and all the libraries and all the support that it has? Well, nowadays there's very good support in the Haskell ecosystem for a lot of things. And honestly, I can't remember the last time the Eureka client that I mentioned, I can't remember the last time that we really had to roll our own utility thing. Generally there are a lot of libraries out there, frameworks now, that take care of a lot of tasks in the Haskell ecosystem. So I wouldn't say I miss it. Yeah.
I wish it had better libraries for machine learning.
All right. Well, thank you very much, guys. Give it up for our speakers.